This week we're releasing two new on-device AI models in Detail and Subwave. Both of these models we trained in-house, and both of them are small enough to run on your iPhone, which means that your recording never leaves your device. They were trained on our own recordings and designed to produce the best output from most recordings in Detail and Subwave. One of the models cleans up the sound of a recording. The other one finds all of the ahs and the ahs that you didn't even notice you were saying. When building these models, we started with the outcomes, because we wanted to get the best sound out of all kinds of microphones, including the built-in microphone of the iPhone in most environments. And we wanted these recordings to come out without any filler words that get in the way of what you actually said. A year ago, building these types of models ourselves would not have made any sense. The benchmark for audio enhancement was Dolby, which runs on their servers and costs us thousands of euros a year on Detail alone. And because almost every feature in Detail runs on device, it enables us to build the best product experience and offer unique features without the massive infrastructure cost. So the biggest problem of Dolby was the actual per minute pricing and the fact that we had to upload and retrieve all of these recordings to enhance them in the app. The per minute pricing on audio enhancement limits what we can offer inside of Subwave, where every post might get cleaned and we don't charge for the product yet. That's why we decided to build our own on-device audio enhancement model using our own data, with zero inference cost and excellent quality. What changed in the past year is that four things became reachable for a small team like us. Open source base models that we can build on, training data that we already had from years of Detail recordings, affordable hardware fast enough to train models overnight, and Claude Code doing the engineering work around the model itself, like orchestrating training runs, preparing the data, writing the pipelines on almost all of the scaffolding. With all four of these within reach of one person, the bottleneck stops being compute and it actually becomes taste. AI features are commoditizing fast, so anyone can ship transcription services now or pull a generic audio enhancement off the shelf, or call an API to remove filler words from a recording. But what doesn't commoditize is the taste. The hundreds of small decisions about what the final output should sound like, where the user gets to make a choice and where the product should do the right thing. When you train your own model, all parameters and training data have become levers in your product. So in this particular case, for our audio enhancement model, the most important parameter wasn't speed or size. Most of the audio enhancement tools really sound like flat or neutral, and they're broadcast safe in a very thin way. And that's not what we want a Detail recording to sound like. A Detail recording should sound warm and present, like you're in the room, closer to a podcast studio than an actual phone call. So the clean reference that our enhancement learns from is itself lightly enhanced and loudless normalized, shaped to the sound that we wanted to hear. The model learns the sound of Detail, not the sound of clean speech in general. The iteration loop looked a lot more like product iteration than research. I would train overnight, listen back in the morning to tens of Detail recordings, compare the new model against the previous best and against Dolby, and then against the unprocessed recording. To do this, I built like this audition tool and set up a blind A and B test with the same source and outputs just labeled blindly A or B. And we would pick the sounds that sounded best on the recordings that we would typically find in our app. And then we would rinse and repeat and do the same training loop again. For the filler word detection, I've evaluated hundreds of clips by hand to validate the quality and improve it. The signal that ended a training run was the blind addition the next morning, not a number in the model card or an API documentation. In the end, we ended up with a 5 megabyte model running on your iPhone, competitive with a server-side enhancement that charges by the minute at zero variable cost to us. Our filler word detection model processes a 57-minute interview in less than 30 seconds. Because the models are ours and cost us nothing to run, we can make product choices that wouldn't be possible if we were paying by the minute. In Detail, auto-edit runs both models without you asking. Fillers come out, audio gets cleaned, and you get a usable edit on the first pass that you can take from there. In the app, if you want controls, they're there as well. You can step through the fillers one by one in the transcript view, keep the ones that feel like you. Or you can move a slider for the audio enhancement to go from very enhanced to almost no enhancement, so that you can get a very natural sound or a podcast studio type sound. In Subwave, every post gets cleaned by default if you want to. The cost is zero, so nothing pushes against making the good version the default. What we're shipping in our products is not the model. It's the sound of a Detail recording or a Subwave recording and the editing taste of a post. The model is how we get there without paying a tax per minute to a generic service that puts the same output to every app. The interesting move in AI isn't the bigger generic models. It's swapping the large generic model for a small local one, trained on the data that you have, tuned to the product that you actually ship. So we started with the outcome, and the model follows.